All right, so what I'm going to do, guys, is I'm going to give you like a picture there on the left, okay? That red line. I'm going to ask you to write the equation for that, okay? Another version of that will be I'll give you the same exact information that line or that graph is producing, but I'll give it to you in words. So if you scroll down, I guess you guys won't scroll, flip to like maybe the third or fourth page, I'll give you something like this. Write an equation of a line that passes through those 2 points, 4, 6, and 0, 10. An example 4 there. And we should be able to write that equation, okay? That information could be modeled in a picture or in sentence form like it is here, but our goal is to be able to turn that into some type of equation. Now, they're going to be linear equations, so what I want to talk about here early on is just some terminology, some phrases that we're going to recognize, some notation, so that we're all on the same page with that stuff so that we can actually get then into the nuts and bolts of actually producing these equations. Just some key terms as we go through an algebra progression from algebra 1 to algebra 2 to college algebra, you start talking about groups of functions, okay? And some groups of functions share similar characteristics, okay? If you have a group of functions that share similar characteristics, you call them a family of functions, okay? So all lines are functions, okay? Unless they're vertical, and we kick those out, those are not functions. But all other lines are functions, and they have similar characteristics. They have similar characteristics visually as a graph, but they also have similar characteristics as an equation, okay? So we cluster those together, and basically the argument is if we can learn some stuff about maybe a handful of those, or a handful of that family, then we can understand the entire endless amount of functions that come from that family. Does that make sense? Okay. You guys have all maybe been in a situation where you hear somebody's last name and you're like, oh, I know some of their family members. Okay. So you already have, before you even know that person, you already have kind of a thought about them, right? Does that make sense? Okay. So the same, I do that now. It's not intentional, and but it's just human nature. I look at my roster every year at the beginning of the year, and I see last names of students that I've had in the past, of siblings that I've had in the past, and I start to formulate preconceived ideas about people. Okay, and now I try to minimize that because you can be completely different than your brother or your sister or whatever, right? But there's going to be characteristics that maybe you share. Okay, so family of functions is that idea. A parent function is the simplest function with those characteristics. Okay, so what I like to think about a parent function is the simplest one, and then your family is essentially like the children of that parent function. Does that make sense? Okay, so you're going to, in other courses, start talking about a lot of different types of functions. Algebra 1 is really concerned about, for the most part, 2 types of functions. Y equals x and y equals x squared. Okay, lines and parabolas. Those are the 2 things that we talk about the most. Okay, we won't talk about parabolas for a while. Okay, so we're mostly going to talk about a linear parent function. Okay, and it's y equals x. Okay, so y equals x is a function that passes the vertical line test. Every x value has one and only one y value. Okay, so instead of writing it as y equals x, we might occasionally see it written as f of x equals x. Okay. So what I want you guys to understand is that we might be going through some problems here later on, and this is just a notation thing that in the past has screwed people up. I want to make sure that you understand what they're doing and why they're doing it. There is nothing wrong with writing an equation of a line that I use the format like y equals maybe like 2x plus 3. Okay? That's the equation of some line. Now, I could also do this. Because this thing here, if I were to graph it, it passes the vertical line test. It means it's a function. And if it's a function, that means y can be replaced just with f of x. It's a notation thing. And just writing it that way with f of x just tells everybody, yeah, you already know it's a function. You already know it passes the vertical line test. Does that make sense? When I write as y equals 2x plus 3, I have to graph it analyze it before I can actually determine it's a function. They jump back and forth between those two notations, and I want you to understand why they do that and what's allowing them to do that. It's because any line that we ever graph, as long as it's non-vertical, okay, every other line except for vertical lines are functions. So if you want to use a y, you can. If you want to use f of x as well, you can. Does that make sense? Okay. Okay, so a linear equation is an equation that models a linear function. Basically what that statement says to us is that the graph will be a line. Whenever I say linear equation, come up with a linear equation, the root word for linear is line. So we should be able to get a graph here. Now, I'm going to give you a handful of different ways that you might see a line written. Now, they use generic terms here. Okay. So what's going to happen is you're always going to have, I'm just going to use the variables y and x right now, but you always have y equals, and there's going to be a coefficient. I'm going to put a box here right now that goes with x. And then you're going to have plus, and then you're going to have a box here. Okay? Now what goes in that first box, okay, these boxes are representing numbers, values. Your slope of your line is going to be right there. The coefficient of your x term is always your slope. Okay? And all of this stuff, guys, that I'm going to show you, I want to prove it to you later, maybe in a week or so, but it comes from your slope formula. Okay? So this equation I'm going to give you right now comes strictly from your slope formula. Okay? And this number here is going to be your y-intercept. Okay, and we'll talk about what y-intercepts are eventually. Okay, it's the next topic on the handout. But what I've got in those boxes are going to be numbers. Now, they can both be positive, they can both be negative. One can be positive, the other one can be negative. Doesn't matter. Okay, we're going to use all of our real numbers, or all of our real numbers are available to us. Okay, and that will be the equation of any line we ever come across. Something also to maybe make note of is that exponent of x right there is an understood 1, meaning we don't usually write it, but if we did write it, we would put a 1 there. Okay? Every single equation that generates a line, the x is going to have an exponent of 1, and that's going to be the largest exponent in the entire equation. Okay? So are there, everybody? Now, do you guys remember before break what letter we were using to identify slope? M, right? Okay. So can I rewrite this as y equals mx? Does that make sense? M instead of slope, the word slope, plus then is it b. Okay, so b is usually the letter that we use to describe what the y-intercept is. Okay? Now, it can be plus and negative. Does that make sense? So you can have a negative y-intercept. Okay? But that's usually the way that you guys have seen maybe linear equations in the past. What I want to write here are just some alternative versions of this. Okay? Some textbooks use a y equals like an ax plus b. Some might use y equals like kx plus c. Some might use y equals rx plus w. It doesn't matter. The number that comes in front of your x, that coefficient, is your slope. The other number is your y-intercept, whether it's a b, a c, a w, whatever. Does that make sense? Okay. And so that middle one is the one you're probably most familiar with. That's the one that you're going to use the most. Okay. But I want you to be aware of this because when you get to Algebra 2, you get to college algebra, maybe the end of course exam might have something written this way. A is in front of x, so that must be my slope. Okay? That must be then my y-intercept. K is in front of x, so that must be my slope. That must be my y-intercept. Does that make sense? So it doesn't have to be those letters of M and B all the time. Okay? Because those are just arbitrary values that are determined by our formulas. Okay. Intercepts. Okay? The word intercept, if you were to Google it, talks about like cutting through the path of something. Okay? Think about if I'm in basketball or football and I throw the ball, let's say I throw the ball to Ollie, and Boston cuts through the path and takes the ball before he gets to him, right? We would say Boston intercepted Mr. Fay's pass, right? Because he cut through the path of something. So when we talk about intercepts in mathematics, it's the same idea, okay? Your line is going to cut through the x-axis and y-axis path, okay? Another way of, now intercept looks and sounds a lot like intersect, right? Okay? When I say x-intercept and y-intercept, it's essentially where my line intersects the x-axis and it intersects the y-axis. Does that make sense? Or intersects is a word, is a synonym for crosses, right? Does that make sense to everybody? Okay. So when we look down here, I just got one particular line there on the left in red, okay, and I'm showing you up there at the top at 0, 3, I get a y-intercept, okay, because that's where this red line crosses through the path of my y-axis, right? Okay. Here's an x-intercept because that's where my red line passes through the path of my x-axis. So those are my intercepts. Is that okay, everybody? Okay. We identify those as ordered pairs. So this y-intercept here would be 0, 3. This x-intercept down here would be, kind of have to guess here, it's probably 3/2 or 1.5, comma 0. Okay. But those are y-intercepts and x-intercepts. You guys seen those words before? Yeah. Okay. Does anybody know what that picture on the right is called? What that shape is? The red one on the left is a line, right? The one on the right is a, anybody ever seen that before? Huh?
Looks like U. I forget what it's called.
Starts with a P.
Oh, what?
Ever heard that word before? Oh, parabola? Okay. That's an O, not an A. Parabola. Okay. If you were to look at like the lens of like your headlight on your car or the lens of a flashlight, like the reflective surface is parabolic. So that shape is very important to us. If you look at like a satellite dish, something like that, satellite dishes are parabolic. These are the types of parent functions, or family of functions, I guess, is a better phrase, that we'll talk about like towards March and April. Okay, so that's the second type of function in this class that we like to investigate. There, you notice you cross the x-axis twice, right? So you have two x-intercepts there, only cross the y-axis once, so I have one y-intercept. Okay, some important information to talk about right here. These things are very, very important, that are always going to be true for lines, okay? Non-vertical and non-horizontal lines. So any line that you can imagine, as long as it is not vertical and is not horizontal, will always have one x-intercept and one y-intercept, no matter what, okay? So if I take, let's see here. So if I have that line right there, would you guys agree that that line intersects my y-axis there and intersects my x-axis there? Would you guys agree with that? So let me just look at C and D real quick. And I don't even care right now what their coordinates are. So let me just get rid of label. Okay. No matter where I move my line, do I always have those two red X's? Okay, now, there it looks like maybe one of them disappeared, right? But if I scroll over here far enough, it shows up, right? So no matter what, my line, as long as it's non-vertical or non-horizontal, I'm always going to have one x-intercept and one y-intercept. That's a feature, that's one of those common characteristics that makes that line similar to maybe that line. Does it make sense? Which makes it similar then to maybe that line. Okay, that they're both or all of them are going to have one x-intercept, one y-intercept. Now, what kind of line is this line right here? That red line is horizontal, right? Does it ever cross the x-axis then? No, it's parallel to it, okay? So do I have any x-intercepts on a horizontal line? No. Do I have a y-intercept though? Yes, I do, okay? And then the same thing happens when I do this, but for x-intercepts. There I have an x-intercept. Do I have any y-intercepts? No, okay? So if you do not have a line like that, or a line like that, then that means you must have a line similar to these two, or not these two, but these kinds, okay? These are non-vertical, non-horizontal, right? So you're always going to have one x-intercept, one y-intercept, okay? Horizontal and vertical lines are kind of a special case scenario of lines that kind of have their own little structures that we'll mess around with in the next couple days. All right. Something to think about. Okay, the next key concept. I think it makes sense maybe in this next one to my computer froze. This program froze. There we go. This idea here says for all x-intercepts, no matter what, they have to exist on the x-axis, right? So if they have to exist on the x-axis, all x-intercepts have a y value that is 0. Think about this. If I look at this point right here, point D, show name and value, would you agree that point D is an x-intercept? That's where I'm crossing the x-axis, right? Is the y value 0? Okay. As I move this line and change the line so I have different x-intercepts, what is the y-coordinate always or going to be of that point D? It's always 0. Okay? Even if it's over here, right? The y value is always 0. That's a key feature to know about x-intercepts. Okay? What is the x value of this point C all the time? Yeah, if I look at the ordered pair of any y-intercept is going to have an x value. So we're looking at C here. No matter what I do, is that x value always 0 on that y-intercept? Is it okay with everybody? Okay. So those are some facts that we need to kind of come to grips with to make our life a little bit easier when we do the algebraic work here in a little bit. X-intercepts always have a y value of 0. Y-intercepts always have an x value of 0. What we like to do, okay, you guys have talked about like y equals, we put slope here, right, times x plus then we put y-intercept here, right, and we changed that, we wrote that as y equals mx plus b. Well, the y-intercept then here, let's say if I look at this point right there, it's at 0, 6, right? 6 would be my y-intercept. Okay? If I was looking at that point right there, 0, 3. That 3 value is this y-intercept value. Does that make sense? So every one of these ordered pairs on your y-axis, when you're trying to pull off of a picture what your y-intercept is, each one of these points is a 0, comma b. Sorry about that. Don't know how. Okay, 0, comma b. You see how that 3 would be this b value, right? That 6 would be the b value. So no matter where that point shows up on this axis, it's a 0, comma b, and b is in whatever that y coordinate was. Is that right? Okay. That's an important fact as well that's going to allow us to write equations quickly. Okay? As we go through the next several weeks, we're going to try, I'm going to give you an example here in a moment that we're going to write our first equation. Then everything that we do from there on out is exactly the same kind of end result that we're looking for. We're trying to, everything we do from the next 2, 3, 4 weeks, we'll be trying to write an equation just like the first one we do here. But what changes over the next 2, 3, 4 weeks is the information they provide us with and how we go about using different techniques to find M and to find B. Does that make sense? Okay. And I'll give you alternative ways of doing it. I'll give you more formats, more formulas that allow you to do that. And the hope is that we eventually develop kind of an efficiency, so we don't always use the longest technique to find the equation of a line. Doable? All right. Now I know you have some experience with this stuff. I like to make sure we all start kind of at ground zero. We all have the same level of understanding before we start doing examples. Okay, so this is the last key concept we want to talk about before we start doing examples. It says each linear equation can be written in the slope-intercept form. Okay, we're going to have several different formats that they give us that have these names. One's slope-intercept, one's going to be point-slope form. When they give us these different names, the names tell us the parts that you are using to create your equation. Slope is one part that we're going to use, and in this case, the next word is intercept, right? So we're going to use a slope, and we're going to use our intercept, and it's going to be our y-intercept to create this equation. That's why we call it y equals mx plus b. M is our slope, b is our y-intercept. Does that make sense? Okay. Now, a lot of people, me included, have always learned it as what? It's y equals mx plus b form, right? Y equals mx plus b form. And we learn how to do it, and we get proficient, we get pretty good at doing this, writing equation y equals mx plus b form. And if I give you those instructions, write this equation in y equals mx plus b form, you're all going to get it right eventually. But then we get to the end of course exam, and the exam says, write the equation of this line in slope-intercept form. Do we know that that's y equals mx plus b form? Do we know? Can we connect those two things? Does that make sense? So I'm going to try to use slope-intercept form, that terminology, so when we get to the end of course exam, and it uses that terminology, we know what we're doing. Okay? When we do this, when we write equations, every equation that we write, unless it's vertical or horizontal. Vertical and horizontal are going to be special cases, and we'll get to those later. Okay? Every other line is going to have a y in it, and it's going to have an x in it. It's going to have those symbols in the equation. Okay? So those black symbols up there, y and x, are going to stay y and x. M and b are going to turn out to be real numbers. They're going to be our m being our slope and b being where we cross the y-axis. Okay? That kind of makes sense? As we look at that, so y as always is the dependent variable. Okay, it's the output, it's the range. Okay, it's that value that I generate when I plug in an x. Does that make sense? When I plug in my input, which was my independent variable or my domain. Okay, m is the slope. M is something we're going to have to find. B is the y-intercept. That's something else that we're going to have to find. Okay. Now, when I say we have to find them, sometimes finding them is going to be really easy. Sometimes finding them is going to be very difficult. Okay, we just have to be able to think about our techniques that allow us to do those things. Okay, so just a reminder, slope is this formula here, y2 minus y1 over x2 minus x1. Those should be subscripts, those 2's and 1's. I don't know why it didn't. Did it print off that way? Yeah. Print off just so. So make sure those are subscripts. They're not coefficients or anything here. That's our formula. We worked on slope before break, right? Okay. That's the first thing we have to do. At any time that you're ever trying to write the equation of a line, you foremost always have to find the slope, no matter what. Okay. The next thing you'll do then is go through and try to find the y-intercept. These first two examples are just trying to get us used to y equals mx plus b form, okay, or slope-intercept form. So it's going to ask you in your homework to look at an equation, and then from that equation pull off the information that's necessary to eventually graph this line. Okay? So what I always like to do is I write my generic form underneath it, and then I just make a one-to-one comparison. If I'm going to, if I'm going to ask what is the slope, we'll make a one-to-one comparison. What is the thing between, or in front of the x in this case, the slope of this line is going to be 5 then, right? Does that make sense to everybody? And then a one-to-one comparison, the b value in this case is -2. So when I'm asked to pull off the slope and the y-intercept, the slope of this line, slope is 5, the y-intercept is -2. Okay? When you choose these values, we always, that first name, last name thing with the signs out in front, you have to pull the signs with it. So B is not just 2, it's -2. Does that make sense to everybody? Okay. And what that is then, guys, is a rule. It is a rule that will generate your line for you. Okay. If you start choosing x values, can you plug x to be 0 in there and get y to be -2? And you could graph the point 0, -2. If I choose x to be 1, I would get the y value of 3, so I could plot 1, 3. If I let x be 2, I could get the y value of 8, so I could graph the point 2, 8. Does that make sense to everybody? I could choose any x value that I want to, plug it in, get the y value that goes back with it, and then plot that. And if I do that an infinite number of times, they're all going to structure themselves in a nice straight line with one another. Okay? So y equals 5x minus 2, 5 is the slope, -2 is the y-intercept. This one down here is a little bit different. Example 2, still asking what the slope is, still asking what the y-intercept is, okay? But is this right now in y equals mx plus b form? No, okay? Now you can rewrite it if you want to, but I like to use the fact that the coefficient of x is always your slope. So would you guys agree that this is the coefficient of x? Now, take the sign with it. Okay? So your slope in this case is -2/3. Is it okay with everybody? It's just the coefficient. It's not, we don't take the variable x with it. We just put the coefficient -2/3. That's our slope. Okay? So our y-intercept then, what's our y-intercept got to be then? -3, right? Everything else. That's your y-intercept. Take the sign with it, and I get -3. Okay? Now, because of the commutative property, could I have really done this? Could I have rewritten this equation as -2/3 x minus 3? Take that thing that's in blue and move it out front. Take the thing that's in yellow and move it in the back. Can we do that? We can do that. We can flip-flop those. And now, is that more appropriate to y equals mx plus b? Okay, so you have choices there. I think the safest thing to do is know that the coefficient of x is my slope. Everything else must then produce my y-intercept. Okay? So that's one thing. So you're seeing maybe the first couple questions in a homework assignment are going to give you the equation and ask you to pull off that information. Okay? Because they're trying to get you programmed to be able to do this next thing. This next example says, what is the equation of a line with slope of -4/5 and a y-intercept of 7? Those are the two things that we always need. Okay, I'm going to be kind of generic here, but the two things you always need to create the equation of a line, you need the slope, and you need a point. Okay, that is on your line. Now, right now, that point is really nice for us to be the y-intercept. Doesn't always have to be the y-intercept, but it's really nice if it is. Okay? Here, it's pretty obvious what those values are. What the slope is, they explicitly tell me my m value is -4/5, right? Do they tell you what B is? They tell me B is, this case, 7, right? Does that make sense? Okay. So they explicitly tell me what the M and B are for y equals mx plus b. It's not always going to be that easy. Sometimes if they want me to find the slope, or I need to use the slope, I might have to actually use the slope formula. Okay. I might eventually have to use another line. Okay. To find the y-intercept. I might have to go through some algebra to do that later on. There's going to be more difficult ways of generating these values. But once I have them, I can take my y equals mx plus b format and just replace the m with -4/5, replace the b with 7. And there's my equation. Is that all right? Is that pretty easy? You guys remember doing that previously, right? I'm going to argue, a lot of you already know what y equals mx plus b is. I'm going to make the argument that in that course that you learned that, you probably at least did this. Okay? Let's do this one. This one's a little bit more difficult. Again, it says what equation in slope-intercept form. So I'm going to have y equals mx plus b. That's kind of the governing format. So I need slope, and I need a y-intercept, right? Okay. Now, do they come out blatantly tell me what the slope is like they did in example 3? No, example 3, they said your slope is -4/5. Blatantly, explicitly, right in your face, told you what it was. Here they don't do that. They hide the slope. And they hide the slope by giving you 2 points, right? If you have 2 points, can you always find the slope between those 2 points? Using the formula. Good. So we should be able to use that thing to come up with the slope of this line that goes through those 2 points. Okay? So I'm going to subtract my y. So I'm going to go 10 minus 6. What's 10 minus 6? Okay, so 10 minus 6 gives me 4 up top. Okay, now I'm going to go 0 minus 4, right? Does that give me -4 on the bottom? What's 4 divided by -4? -1? Okay. Now if you went, you're going to send me, if you go 6 minus 10 over 4 minus 0. If I flip-flop, if I go 6 minus 10 and 4 minus 0, so switch the order, right? I'll get -4 over +4. Still -1 though, right? Okay. So I get -1 as my slope. Okay. Now, I need my y-intercept. So here's where it makes sense for us to be able to recognize what that point right there is doing for us. Okay? If I were to quickly sketch a graph of those 2 points, 4, 6 would be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 4, 6 would be right there, right? Is that y-intercept? Is that where my line crosses the x or the y-axis? No. But if I graph 0, 10, 7, 8, 9, 10, isn't that point right there my y-intercept then? That's where I cross the y-axis. That's 0, 10. Didn't we say previously that every single point, when you make a line, every single point that is a y-intercept is of the version 0, comma b? Does that make sense to everybody? So, if 0, 10 is that point right there, it's of the version 0, comma b. Does it make sense that for this particular case, b is 10? We okay with that? Okay. So I'm going to write my equation, y equals mx plus b, -1x plus 10. So that's a little bit more difficult than the previous two because they ask you to find the slope, and they ask you to look at those ordered pairs and kind of decipher, is one of those a y-intercept or not? Okay? Now let's look at example 5, and this is probably this will be the last one we can do. Example 5 says, what equation in slope-intercept form represents the line that passes through the points 2, 1, and 5, negative 8? Okay? Do they blatantly tell me the slope? No. So I got to go through, just like the last one, I got to go through this formula, right? So I'm going to go negative 8 minus 1 over 5 minus 2. So negative 9 over 3 gives me negative 3. Is everybody okay with that? We have our slope. But if I were to graph this real quick, 2, 1, is that a y-intercept? 5, negative 8, is that a y-intercept? Are those 2 points I just plotted y-intercepts? Either of them? No. So I can't do what I did in example 4, right? But there is a strategy that we can use here. Okay? We know y equals mx plus b, right? We just figured out that m was negative 3. We don't know y, x, or b right now, right? But think about this. Is that value an x? Is 2 an x value? So let's put 2 right there. Is this value here a y value? Let's put y right there. Or that 1 right there. So if I do this, 1 equals negative 3, x was 2, plus b. Does that give me an equation I can solve for b? 1 equals negative 6 plus b, right? What's b going to be? We're going to plus 6 to both sides, right? So b is 7. Can I go back to my y equals mx plus b now? What was m? Negative 3, right? What was b? B ends up being 7. Okay? No matter, we'll get many more problems like this to practice this process. But no matter what they do, if they give me 2 points, I will always have enough information to write the equation line. Whenever you have 2 points, that's enough information. You just then have to find the slope and the y-intercept to do that. Okay? Something that I think is important, guys, and I know I told you that I don't want you having your computers out, okay, but over the next couple of weeks, you can have your computers out, but I want you on Desmos for this purpose. If I graph my line, okay, I just type that in right there. Now what I'm going to do is I'm going to type in the points 2, 1, and then the point 5, negative 8. Do they both show up on that line? That make sense? And if they're both on that line, that guarantees me that was the right equation. Okay? If I would have had something like this, do those 2 points show up on that black line? No. So that tells me that equation is wrong, right? It's not the equation that was to be created with that given information. Okay? Keep that packet. We're gonna, like I said, we'll probably use that packet for most of this week, at least probably up till Thursday. There is an assignment on Math Excel. It's not due tomorrow. You could probably do a chunk of it this evening. Hopefully by the end of tomorrow you can be able to finish that.